Hello students, welcome to Sri Vardhaman Vidyalaya Online Education. Today we will see the part 4 of chapter 9, Force and Law of Motion. In this part we will discuss about the law of conservation of momentum and their derivations and the applications of a law of conservation of momentum. So first we will discuss what is the conservation of momentum. In the second law of motions, we have studied that the moving bodies possess momentum, which is equal to the product of mass and velocity. So we have discussed in the part 3 about the momentum. So momentum is equal to mass into velocity. We will now take another example to understand the meaning of the term conservation of momentum. Suppose a speedy truck hits a stationary car, due to which the car also starts moving. Now, in this collision, the velocity of the truck decreased, but the velocity of the car will increase. So, due to this, the momentum of the truck decreased and the momentum of the car increased. So, it has been found that the increasing in the momentum of the car is equal to the decreasing in the momentum of a truck. So, there is no loss of momentum in the collision. So the momentum lost by the truck has been gained by the car. This is an illustration of law of conservation of momentum. So according to the law of conservation of momentum, when two or more bodies act upon one another, the total momentum remains constant providing no external force are acting. So in this one you have discussed that the when a two body will be act upon or they will be collide with each other, what happens? The total mass of a momentum or total momentum will remains constant. Okay, so now we can derive the conservation of momentum. So conservation of momentum, if one or more bodies apply the force on each other with no external force, their final momentum remains same as an initial momentum. So the total momentum before collision is equal to the total momentum after collision. So the mathematical formulation of a conservation of momentum. Suppose two objects A and B, each of a mass m1 and m2 are moving initially with the velocity u1 and u2 strike each other after the time t and start moving with the velocity v1 and v2 respectively. Now you can see the diagram. In this diagram, there is a two object, the object A with a mass m1, the object B with a mass m2. They move with an initial velocity. So for an object A, the initial velocity is u1, and for object B, the initial velocity is u2. So after a time t, what happens? They will be struck with each other or they will be collided. So what happens? This is during collision. So the force exerted on A to B and force exerted on B to A. After collisions, there will be the object A with mass m1, but the velocity will be changed into v1, and another object B with a mass m2 and the velocity is v2. We know that the momentum is mass into velocity. Therefore, the initial momentum of an object A is equal to m1 u1. Then the initial momentum of the object B is equal to m2 u2, and the final momentum of the object A is m1 v1, and final momentum of the object B is m2 v2. Now the rate of change of momentum is equal to change in momentum upon time taken. Therefore, the force exerted on A to B, so FAB is equal to m1 v1. So that is in an A. So the final velocity is m1 v1 minus m1 u1 upon t. So that is equal to m1 is common, so we can write v1 minus u1 upon t. Now same thing, the rate of change of momentum in B during collision. So the force exerted B to A, so that is m2 v2 minus m2 u1 upon t. So in this one m2 is common, so we can take an m2 common, so m2 bracket v2 minus u1 upon t. But from Newton's third law of motions, we know that is in every actions and reactions there is equal and opposite. Yes. So reactions and actions are equal and opposite. So we can write FAB is equal to minus FBA. So m1 into v1 minus u upon t is equal to minus m2 v2 minus u1 upon t. Now in this both the tt will be cancelled. So what about the equations m1 v1 minus m1 u1 is equal to minus m2 v2. So you have to multiply minus in this one. What happens? It will become plus. So plus m2 u2. Now bring this m2 v2 in this side and m1 u1 in this side. So what happens? m1 v1 plus m2 v2 is equal to m1 u1 plus m2 u2. So this will become an what final momentum, and this will become an what initial momentum. So the total initial momentum is equal to total final momentum. So this you have to derive, so that we have derived. So that is a total initial momentum is equal to the total final momentum. Now same thing you can see in a truck. If it is in a truck, so we have seen the example of a truck and the car. Okay, so same this we can see in the truck. The law of conservation of momentum means whenever one body gains a momentum, then the other body will lose an equal and opposite momentum. This law also can be stated that the momentum is never created or destroyed. This the law of momentum is also known as the principle of conservation of momentum. The principle of conservation of momentum is in accordance with the Newton's third law of motions, which says that actions and reactions are equal and opposites. We will now take an example to prove the law of conservation of momentum. Suppose two bodies, a truck and car, are moving in the same directions but with a different speed and velocity. So let the mass of the truck be m1 and its velocity be u1, and initial momentum is m1 u1. So the mass of the car be m2 and its velocity will be u2. So the initial momentum is m2 u2. So the total momentum of truck and the car before collision is m1 u1 plus m2 u2. Now you can see the diagram. So this is before collision. So the mass of momentum will m1 u1 plus m2 u2. There will be the collisions will be take place. After collisions, the momentum will be m1 v1 plus m2 v2. So suppose a truck and the car collide for a short time t. During collisions, the velocity of the truck and the car will be changed. So the velocity of the truck after collisions be v1, and for a car the collisions will be in a v2. So the momentum of the truck after collisions will be m1 v1, and the momentum of the car after the collisions will be m2 v2. In this way, the total momentum of a truck and the car will be m1 v1 plus m2 v2. Now we can see that suppose that during collisions the truck exerts a force F1 on the car, and in turn the car exerts a force F2 on the truck. So we can find out the value of force F1 and F2. This will be done. When the force F1 of the truck on the car for the time t, the velocity changes from u2 to v2. So the acceleration of a car A2 is v2 minus u2 upon t. So the force is equal to mass into acceleration. So the F1 is equal to m2 into v2 minus u2 upon t. Now this will become the equation 1. Same thing you can see for the truck. So for the truck, it is a force is F2. So the acceleration is a1. So that is the velocity will be v1 minus u1 upon t. So the force is equal to F2 is equal to m1 into v1 minus u1 upon t. Now using a Newton's third law of motions, so force F1 exerted by the truck is the actions and the force F2 exerted by the car is a reaction. So according to Newton's third law, F1 is equal to minus F2. Now put the value of F1 and F2 from the equations 1 and 2. We will get m2 into v2 minus u upon t is equal to minus m1 v1 minus u into t. Here from this t will be cancelled. So the equations will become m2 into v2 minus u1 is equal to minus m1 v1 minus u1. Now you can multiply the minus in this one, so this will become plus. Now take this m1 v1 minus in this side and m2 u2 in this side. So you will get m2 u2 plus m1 v1 is equal to m2 u2 plus m1 v1. So this will become an total momentum of the truck and car before collisions, and m1 v1 plus m2 v2 will be total momentum of an truck and car after collision. So this means that the total momentum before collision is equal to total momentum after collision. So this absolutely the total momentum of two bodies before and after collision is same. This means the momentum of the two bodies remain constant, as this result proves that law of conservation of momentum. So now we can discuss some important applications of law of conservation of momentum. So we can see the application. So before applications, we can see the activity. Take a big rubber balloon and inflate it fully. Tie it with a neck using the thread and also applying an adhesive tape. Fix a straw on the surface of this balloon. Press on a thread through the straw and hold one end of the thread in your hand or fix it to the wall. Ask your friend to hold the other end of the thread or to fix it to the wall at the some distance. Now remove the thread tightly on the neck of the balloon. Let the air escape from the mouth of a balloon. Observe the directions in which the straw moves. So the straw will be moves in this directions. Same thing. Activity 6. Take a test tube of a good quality glass material and put a small amount of water in it and place on a stopcock at the mouth of it. Now suspend at the test tube horizontally by the two strings or a wire that you can sew and heat the test tube with a burner until the water vaporized and the cork blows out. Now observe the test tube recoils in the directions opposite to the direction of cork and observe the difference in the velocity of cork appear to have and that of recoiling the test tube. So both are different. Now we can see the application of a law of conservation of momentum, that is propelling of rocket. The chemical inside the rocket burns and produces a high velocity blast of hot gas. So this gas gets ejected downward with a great speed to conserve the total momentum of gas. So the rocket will move up with a large velocity. Now you can see this is a rocket. So in this rocket, a lot of gas will be blast from a high velocity in the downward direction. So due to this, what happens, the rocket will move with a large velocity in the upward directions. Now same thing, you can see the flight of a jet plane. In the jet plane, large volume of gas produced by the combustions of fuel is allowed to escape through a jet in the backward directions. So the fuels will be moved in the backward directions. So this due to the high velocity backward moving gas have a large momentum. In order to conserve the momentum, so the plane get pushed in the forward directions with and moves with a great speed. So you can see that this is a jet plane. So you can see that that is a large volume of gas will be moving in a backward direction. So due to this, what happens, that is a plane get pushed in the forward directions with a high great speed. Okay, now students, take the page number 2. So you have so many problems in this chapter. So you have to write in the page number 128 the question number 1, 2, 3, 4, 9. Okay, and others are the problems. So you have to finish in this notebook. And also the page number 126, that is the question number 1, 2. You have to write in your science notebook. Thank you. We will meet in the next part of this session, that is also numerical part of this chapter, that is force and law of motion. Theory part is over. So in this chapter only the numericals are remain, so that we can see in the next part. Thank you.